Hello, everyone. Welcome. Thank you so much for joining us today. My name is Sierra King, and I'm the Director of Admissions and Program Services at the Data Incubator, and we are a fellowship, scholarship, and placement company. We promise you an excellent info session today that will be led by one of our instructors, Don Fox, and Don will be reviewing Git and how it works. But to start things off, I would like to give you a quick overview of our programs and everything that we offer here at the Data Incubator. And then I'll hand it off to Don, who will lead us through our discussion, and we'll leave some time for questions at the end. Just a couple of housekeeping items. Today's session is scheduled to last 1 hour, including a Q&A session. All participants are muted to enable speakers to answer as many questions as possible. We ask that when you do submit questions, you submit them through the Q&A box. There is a chat box there. It will be used for general announcements and resources. So we just ask that you avoid putting questions in the chat box so we can make sure that we can answer as many as possible and we don't miss your question. If you do have a question that you don't feel comfortable asking in this group setting, or maybe potentially we run out of time, we don't get to your question at the end, you're more than welcome to email us at admissions@thedataincubator.com, and we'll be happy to schedule a call outside of this session. And a recording of this session will be sent to all registered attendees approximately 72 business hours after we conclude the session today. So we're going to start off with an instructor introduction. So Don, if you could introduce yourself.
Yeah, hello. Hello, everyone. My name is Don. I'm one of the instructors here at TDI, and I'm based, I teach on the data science side, ranging from the basics to our advanced curriculum, and I'm based in New York.
Thanks, Don. So we're going to go into a quick overview again of everything that we offer here at the Data Incubator. So the Data Incubator focuses on training people to become data scientists and data engineers. And why is that important? Well, it's really because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value for them. This is a big need in the world right now. We work with companies in a variety of industries, ranging from tech, finance, to retail, healthcare, and many more. Every company has data and wants to use that data to drive value for them. So we know there are a lot of other data-focused programs out there. So I'm sure you're wondering what we do at the Data Incubator that's just a little bit different. Well, what we found is when you look at training, there are two different types. One being fast-paced and efficient, and the other slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but potentially with a lot more time invested. And on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. Well, what we've done here is we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You'll walk out of the program knowing a lot about data science and data engineering, but most importantly, it's based in real-world business applications, and you'll also receive a deeper understanding similar to what you would receive from university. All of our instructors are PhD and master's holders, and many of them have completed this program themselves, so they know how to provide that in-depth training that you're looking for. For our spring 2023 cohorts, we are offering 3 data-focused programs. We're offering our full-time data science program, a more flexible version of that with our part-time data science program, and also we are offering our full-time data engineering program. I want to take some time to review all the similarities of our program offerings. All of our programs are very intense. They are built around hands-on data-focused curriculums, and we offer both full-time and part-time programs for our data science program, and both are packed with a lot of information and tools. Each week in the programs, we'll focus on a different data tool or approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. And so in each program, students will work on mini projects that focus on that data tool that they're studying for that week. Additionally, our programs are very collaborative. We want our students to not only work with their colleagues and instructors, but just to also have the opportunity to network and connect with our hiring partners. And in addition to that, our programs are very career focused. We have career coaches that help you succeed in your data-focused careers. You'll not only learn how to present your best self by attending our weekly career search workshops, but you'll also have the opportunity to work with a top resume writing company to get a polished resume and cover letter. And then lastly, all of our programs are interactive. Every student in our program is provided a Jupyter server for the duration of the course, so students can follow along in the lecture and see and edit raw code as it's being run. And you'll also receive immediate feedback via our interactive grader. So for our full-time data science program, this program lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week working on assignments. Here's a quick overview of our full-time curriculum broken down by the different modules you'll study. If you'd like a more detailed overview, please email us. We'll be happy to send a more detailed curriculum. Similar to our full-time program, we have our part-time data science program. This one lasts for 20 weeks with classes held on Tuesdays and Thursdays from 7 p.m. to 9:30 p.m. Eastern. And you can expect to spend about 10 hours per week working on your assignments outside of class, and office hours are also available each week. You will receive the same excellent curriculum and training as our full-time program, but at a slower pace. The sessions are still live and instructor-led, so you're able to interact with your instructors and peers and ask questions. And then similar to our full-time data science program, we have our full-time data engineering program. These classes also last for 8 weeks with classes held daily. Again, you can expect to spend about 40 hours per week working on your assignments, and a quick overview of the curriculum broken down by the different modules. Again, if you'd like a more detailed curriculum, please email us. We'll be happy to connect you there. So this is just a little bit about our TDI programs. I'll now pass to Dawn to lead us through our presentation, and then I will come back on at the end to help answer any questions.
All right, thank you. Let me just get a little, I like to have a little timer on my phone to see how I'm doing on pacing. Welcome everyone to our demonstration. And I was talking to a recent alumni of ours, and I was asking her, now that you've been on the job for, I think it was 2 months at the time, I forget, a month or 2 months, I asked her, what was the most helpful thing you learned in the program? What's the one thing that kind of really helped you out when you started the job? She gave me 2 answers. One is Spark, which is a distributed computing framework. We spend a whole week in both the data science and engineering program talking about Spark. It's a very advanced topic. And she also said Git, version control software. Git is a version control software. And I kind of like this answer because it kind of tracked what I hear from people who say, what are the skills they wish that people who are just joining the industry would be more comfortable with? And that is Git, this version control software. So I said, you know what? I think it's very important that people understand what Git is from the ground up and really be comfortable with it. So when you get into the industry, you can start collaborating with your colleagues. Now, let me backtrack. What exactly is Git? I mentioned it's a version control software. So basically, Git is a version control software, for the 4th time I said it, and it's going to allow people to easily track the evolution and the change of a code base. Right? Code base is just a fancy way of saying I have a directory, and these are all the files associated with that project or that code. And it's going to allow people to see how it changes throughout the development cycle. And Git isn't the only version control software out there. However, it's the most dominant one. It's frankly probably the one you'll encounter. There are other ones out there, Mercurial, Subversion, but Git, for certain reasons, have become the de facto version control software in industry. You're going to have to use it if you're in software development. You're going to have to use it whether you're in data science or data engineering. Anytime code is present, there's got to be a version control software, and Git is the one that people are going to primarily use. So before we talk about what features of Git and how it works, let's ask ourselves, well, what do we want from a version control software? What are the features we want from it? Well, we want to be able to keep track of the different stages and states of our project. So I'm going to go and share my screen here. Let me go ahead and give me a sec while I get that set up. Should be sharing my screen now. Let me just move a couple of things over. So I said we got to be able to easily keep track of the state of our project. So you can think of this little circle here represents a snapshot. Right? Think of a snapshot of the code, the files of this code base, and be able to easily relate to future snapshots of our code base. So each of these dots represents a different snapshot as we progress and we add more features, improvements to our code base. And notice the arrow? That arrow relates to where it came from. What previous snapshot did it come from? Right? So we want to keep track of this history of our project through this manner. We also want to determine the who, what, when, where, and why of the changes introduced to the code base. So the who, so who made a change? Where was the change? In other words, what file was changed? When was it changed? and the why. Why was it changed? Why did we add this feature? Why did we change this part of the code? We want the who, what, when, where, and why. Just kind of like in journalism, or remember, maybe in grade school, you were reading an article and summarizing the who, what, when, where, why. We want to be able to fetch this information from our version control software. The who, what, when, where, and why will make references to this and how it relates to where it shows up in Git. We also want to easily maintain different versions of our project. We want to be able to easily create a different version of what we're working on and be able to easily switch between the different versions and bring in the changes from one version to the other. Imagine we're working on our project and we want to try out a new feature. So we want to be able to easy way, we can kind of a clean way to create the new feature, be able to easily go back to what we had before. This easy of working different versions of our software. And this is done through branches, as I'll speak to more later. We also want to find sort of easy way to collaborate with people, right? Rarely is working with code we're done in isolation. Sometimes that does happen, but we want to use a tool that's going to make it very easy for other people to collaborate. And that's one of the things that Git is going to introduce. Okay. So one of the things when I was learning Git, and I get this from other people as I talk to them about their adventures, their journey about learning Git, they often feel like they're using the command line and they're just doing these incantations on the command line to do something. Git add, git commit, git stash, git revert, git checkout. They don't really know what these incantations are, right? Sort of like saying some spell and just kind of memorizing it and hope for the best, right? And I don't really like this because that's right. We kind of memorize what we're doing and we don't really know how it works. So that's why I want to talk about how Git works really from the bottom up, right? So lots of things I'll be doing now is actually I'm not going to be working the command line for the first half. I'll be talking about demonstrating how the internals of Git works. Because if we know the philosophy and how Git works, sort of how it ticks, so to speak, then we can have more confidence as we invoke those Git commands, the command line, right? They're no longer feel like some incantation of a foreign language. We can actually say them with conviction. We can actually know what's going on and the confidence and the fluency as we work with Git. Okay, so let's talk about the Git data model. As I mentioned earlier, what we're essentially doing is we're creating snapshots, records of states of our project. Think about our project as a directory with all the folders and files related to that project. Now, those folders can have other files and other folders and so forth. Right? We're going to keep track of the state of this project. And each of these snapshots I'm depicting as a dot. These are called commits, a snapshot of our history. And notice what we're building here is kind of like a graph. A graph is essentially nodes and vertices that are attached to each other. And the concept of graphs is going to show up in computer science. It shows up in data science. It shows up in data engineering. Very common, this idea of graph. And we're building this graph. And these arrows point to the parent commit. So this is the root commit, the first commit. This is a second snapshot. And this snapshot is saying, you know what? I was derived from this one. And this one here is saying I'm derived from that one there. So in Git, the data model of Git, the first object you might encounter is this commit object, a snapshot of our project. Well, that snapshot, what does it contain? Well, it contains a reference to a tree, basically the state. These trees then point to what are called blobs or files that represent that state, right? So we have the commit is pointing to a tree, a directory, folders, and those trees then point to files that make up those folders that represent that state. But we also have metadata regarding the commit. And we'll see this metadata once we start working the command line. But this is where the who made the change, where the change was, when it was made, and the why. Recall that we want that information as we keep track of the history of our project, because we want to be able to easily look up what's going on with the project, what were those changes, who made them, when they made them, and why they made them. So we're creating this data structure here, this graph data structure in Git with these commits. We also have the tree object here. As I mentioned before, it's basically an object that points to files, and we have the files object. And as we're going back to what I said earlier, it's going to allow us to keep track of different versions of our project, because you can think of this line here as the main history of our project. change. But what it allows us to do is to branch off. And we can continue with this branch, but we're also allowed to continue on with this other branch. And Git is going to make it very easy for us to switch to what version of the project we're working on. Are we working on the main master branch, as it's called? Or did we switch checkout to a different branch? And we're creating changes there because at a later point, we might want to bring those changes into master. Make it very easy to compartmentalize our work. While we're working on something, we might have to fix a bug, but we might want to add a new feature, and we can easily switch to different versions that fixes the bug and adds a new feature. I'm going to demonstrate that in the command line later once you start working Git to use those Git commands. And these snapshots, these commits, we want to have a way to reference them, right? Because we might want to make references to the different commits in our history, like see the difference this snapshot introduced from its parent and so forth. Well, what Git does is that it generates a hash value for these commits. And I won't talk about what exactly are hash functions and hash values, but you can think of a hash function as basically some function that accepts data and it spits out a number, sort of ideally unique number to that data. So it's going to use a hash function to create a unique identifier to these commits. And these commits are snapshots. So you can imagine that we can take that snapshot, that the files that represent that current snapshot, and be able to lay them out all, on disk or memory, with, ones and zeros, or run into the hash function to create that unique identifier. And this is where these SHA values will show up, as I'll demonstrate with the git log command. Well, that's great that we can reference those commits through some sort of hash value, but Git also gives us different ways to reference objects in Git. For example, there are things called branches. And what essentially a branch is a reference that points to a commit. So remember I said that this right here was the master or main branch? Well, the reason why is because there is a pointer, think of it as a sticky note, called master or main. This branch might be a branch where we're adding a new feature. So there is a sticky note that points to the latest commit on this different line of history. I'll call this here F for adding a new feature. And I said these are sticky notes because what's going to happen is that if I am on the feature branch called F here, and I add a new snapshot, I record a new snapshot. I'm thinking if you're using a camera, I'm using a clicker thing because I'm old-fashioned. I remember growing up using cameras like this. So let's do our phones. We add a new commit, and this commit points to its parent, but this reference, this sticky note, then moves to point to the latest commit. So I can erase this, and now it points to this latest commit here. So to summarize, when we're working through Git, we're building this graph data structure. It is a directed acyclical graph. Directed because the nodes have a direction. They point to their parent. It's called acyclic because you're not going to have cycles in them. And it's a graph. In fact, this DAG, as it's called for short, this concept of DAG is going to show up when you talk about Spark. When you learn about Spark, it's going to show up when you talk about TensorFlow. They're ubiquitous in computer science and data engineering and data science. Not going to avoid them. So you can start thinking about, with Git, we're building this graph structure that represents the history of our project. These dots represent different states. They depend on a previous state, except for the first one, because it's the root. Each state has a set of metadata, as we'll see, a message that indicates to us who made the change, when they made the change, and ideally why they made the change. Git allows us to work on different branches of history. And what a branch is basically a sticky note that points to a commit. And when we're on that branch, when we add a new commit, that pointer, that sticky note just moves. It's a mutable reference, as it's called. Mutable is just a fancy way of saying that it can change. I'm going to add one other name tag here, one other reference. And that is something that you will start encountering through Git that a lot of people are a little confused about. And that's called head. Now, head's a weird name, but I'm guessing it comes from the name from cassette heads, right? That head of the cassette that tells us our current place. Right? Head is going to tell us where we currently are. And by default, head points to the current branch. So head oftentimes points to a branch, and that branch simply points to a commit. So when we add a new commit right here, what's going to happen is that the master branch or the main branch, it's going to move to the latest one. And since head points to main or master, it still points to main and master. It's just that now that main and master point to a new commit. Now, when we want to switch to a different branch, we have to move head. Instead of pointing to the master main branch, we want head to point to, let's say, the feature branch, what we called F. So we're going to have to check out master. Think of checking out a book from the library. We're going to check out head to point to not master, but to feature. So head tells us where our working directory is currently at, where we currently are in this branch, in this history of our project, what snapshot. Oftentimes it points to a branch, and that branch points to a commit. And since branches are mutable, when we add a new commit to that branch, then that sticky note moves to the new one. And since head points to the branch, then it moves it as well. All that Git is really manipulating this data structure. Now, we'll have this mental model when we start getting to the command line. Now, what I'm going to do here is I'm going to switch to the command line. Let's actually start using Git. So here I have my terminal open. I'm in a directory called Git demo. What I want to do is I'm going to create a directory. I say mkdir, it's command to create a directory, mk make directory. I'm going to call this conversions. I'm going to call that conversions. I'm going to type in ls to see what other contents are in there. I have conversions, I have Linux. Let me cd into conversions. In other words, let me change my directory into this conversions directory. As I said before, a repository or code base or code repo for short, is basically a folder that's under version control with Git. So right now, this isn't a Git project, a Git repo. We have to initialize it. So that's where we're going to say git init. And all the commands we do through Git are always going to be prefaced as git something, git subcommand, and so forth. So that initializes the empty directory. And notice it said .git. What's happening here is that if I type in ls dash those options, I notice there is a directory called .git. What's going to happen is that, remember this data structure I have here, these objects that represent commits. And these commits point to trees. Those trees point to files and blobs. Well, all those objects are stored in the .git directory. We're not going to modify the .git directory directly, right? Git's going to do that for us. But everything it needs to keep track of the state of our project and to manipulate this graph structure is in this directory. In fact, let me go into it. Like I said, you're not really going to muck around in here yourself, but there it is, right? There's a folder called branches. There's head. There's some sort of configurations. There's objects. In fact, if I can look at head, it's probably blank, right? Now blank is saying it's going to point to master. We'll talk about that later. But let me cd back into the project here, back to the root of the project. Well, let me do git status, right? Let me tell Git to give me a status report of what's going on here. We're on the branch master, and there's no commits yet. We haven't done anything. There's no history to the project. So let's go create a file and start playing around with the command line in Git and make references to that data structure that I just talked about. I'm going to use the text editor Vim Doesn't have to matter what text editor I use, but I'm going to use Vim. I'm going to open up a file called temperatures.py. And let's say I want to create a function that converts Celsius to Fahrenheit. I'm going to find a function. I'm going to say convert C to Fahrenheit. It accepts a variable called deg C. I'm going to make a mistake here on purpose. And I'm going to say that the equation from converting Celsius to Fahrenheit is that we need to add 32 first, and then multiply by 9 divided by 5. It's a mistake. Make it on purpose so we can see what we can do next. I'm going to save this file. I'm going to do git status. Hey, Git, tell me what's going on here. Well, I actually created a file called 1, but let me just erase that. Let me do git status again. Not gut status, git status. And it says there's an untracked file called temperatures.py. In other words, there's a file in this repository that Git isn't tracking, Git isn't keeping track of. So we want to go ahead and make this be part of a snapshot. We want to create a snapshot that has this file in it. So what we're going to do with Git is that we're going to stage the changes into what's called the staging area. And once we're ready, we then create a snapshot. And creating that snapshot then creates a commit object into that data structure graph we are creating. We'll git add temperature py. We're adding the file to the staging area, and now we're ready to package it up and commit it into history. Create that snapshot into history. Do git commit. And when we add a commit, recall that there's some metadata attached to it. Recall about the who, what, when, where, and why. Well, this commit message is where we tell about the change. What was the change? And perhaps even why we made this change. So the way to do that, we say git commit, and we use the -m option or flag, saying what's going to come next is a string that's going to be the git message, the git commit message. I'm going to say add conversion from Celsius to Fahrenheit. I'm going to make sure that this git commit message is in the imperative tense. Very strong convention in Git. We have this in imperative tense. You can think of the message is going to follow with this commit. We will blank. We will add conversion from Celsius to Fahrenheit. We don't want this commit message to be too long. It should be short and sweet. In fact, if we are struggling to write a very concise message, maybe that is telling us that our commit is doing too much. We'll talk about that later. I'm going to hit add. Cool. We've created a snapshot. So now, if I were to go back to the whiteboard here, our project's history is simply made up of one commit, one snapshot, nothing else. Well, how do we see this snapshot? Let me go back to the command line. I'm going to say git log. Git log retrieves us this history of the project. More specifically, it's going to show us in some format the data structure we're creating. These nodes, these snapshots, and how they're connected to each other. Let's break this down. Ooh, commit, and this, you see this very long number, and you're wondering, is that really a number because it has letters like A and E? What's a hexadecimal number? This is the hash value. Specifically, it uses the SHA-1 hash function to generate this identifier. Recall that every commit has a specific identifier where there it is. There is that immutable specific identifier for that commit. The who, right? This is the person who made the change. When, here it is. So we have the who, the when, the where. We can do git show to show us, what files was changed. So that's the where, where exactly in the code base was this change introduced. And notice here is our git commit message, the what happened, but now about the why. If this change needs some sort of explanation, in this case, it doesn't, right? But imagine we're going to introduce a change where I should perhaps include a why message, why I'm making this change. Then I can have a longer git commit message that explains the why. So you can start seeing that this git log command is a great way for us to familiarize ourselves with the code base. It's a record of what's going on, of the snapshots, how the snapshots relate to each other, the who, what, when, where, and why of our project. So right now we just have a single commit. It's kind of boring, right? Let's add another commit. Let's add one more commit right now, at least one more. I'm going to open up temperature PY again. Now I'm going to make another function that says convert Fahrenheit to Celsius, accepts degree F. So I'm going to do the reverse conversion. And I believe the equation for that is I should subtract by 32 and then multiply by 5 divided by 9. Save that. Now I do git status. Hey, Git, tell me what's going on. Well, now since I'm tracking this file, it tells me what has been modified. Modified temperature PY. Well, what if I want to see what that modification was? Right? Oftentimes when we're working on a project, you make a change, you're like, oh, wait, I wish I knew what that change was, right? I changed something, I want to kind of go back to what it was before. What exactly did I change? Well, if I'm using Git, it's got my back. Git diff, it says, hey, you're adding these lines to this file here, right there. Oh, cool, right? If I forgot what that change was, Git diff's got my back. Now, I want to commit this to my project. I want to create a no snapshot to my project that represents this change, that has this change based upon the previous snapshot. Well, let me go and add the change. So I do git status. You can see it's been modified. Git add file. Git, a little helpful, try to tell you what to do next. Git add temperature PY. Then I'm ready to create that snapshot. Git commit. Let me go and add a message. And this message, short and sweet, add conversion from Fahrenheit to Celsius. Git log, and there are my two snapshots. And notice when someone looks at my project, gets a hold of my Git log, they can see how it's changing, right? I've added messages that hopefully are readable, self-explanatory. Add conversion from Fahrenheit to Celsius. Add conversion from Celsius to Fahrenheit. Cool. I think that's cool. We imagine a fellow developer or us ourselves wanting to know, wait, hey, how is this commit different? What changes did this snapshot introduced compared to its parent? Because now I have these two snapshots. And let me add those references. I'm on the master branch, M, and head points to master. And recall that all these commits have a unique identifier that doesn't change. So what if I wanted to know what change did this commit introduce based upon its parent? Well, I can do git show followed by an identifier to the commit I want to show, specifically the object, or more generally the object. And I can go ahead and copy this hash value and paste it, and notice it showed me what the change was. So I know if I want to know what the change was, going back to the who, what, when, and where, and why, there it is. Oh, they've added this line. They've added these lines of code. Now, I'm not sure about you, but it was kind of tedious how I had to copy the entire hash value and paste it to show the change. Well, Git is nice where we only need to write enough of the hash value that it's unique. So if there are no other hashes, there's no other objects in Git that have 4763, then there is no ambiguity, right? So you can shorten it to 4, 5, or 6 sequences. More conveniently, recall how our data structure looks like. If we want to show the difference between this snapshot compared to its parent, well, it has that unique identifier. Recall there is a branch called master that points to it, and there's something called head that points to master that points to this commit here. So we can go back to the command line and say git show master. It's the same thing. We can also say git show head, and there it is. And not only that, we can say git show tilde1. Tilde1 means one before head. So now we're showing the change of the snapshot one before our current head. So hopefully by now as I do these, what might feel still incantations, I'm referencing how they relate to the data structure we are building and maintaining through Git. This data structure represents the history of our project. Now, the one thing I want to talk about are branches. I haven't talked about branches. So let's say I want to, typically a good way to use Git is that you don't modify the master branch directly. Instead, you create other branches, work on those, and then once you feel like you're ready, merge them into master. So let me demonstrate this workflow. So I'm going to create a new branch. I'm going to say git branch, and the name of the branch I'm going to create. I'm going to create the Kelvin branch. I hit enter right there. Git branch Kelvin. Let me do git status. Currently on the master branch. So I got to make sure I check out to Kelvin. In other words, I want to make sure that the head points to the branch Kelvin, because right now, what I've done is I simply created a reference to this commit here. I'll call it Kelvin K. So now this commit here really can be referenced four ways, right? It can be called master, can be referenced to master, Kelvin, head, and its unique hash value, its unique SHA-1 value. But by doing git checkout Kelvin, what I am then doing is I'm moving head, that sticky note, to point to Kelvin. So if I go to the command line, let me create the change. Let me git checkout Kelvin. Let me do git status to get a little, tell me what I'm at. I'm on branch Kelvin. So git status, great way to say, hey, what's going on here? What branch I'm on? What changes are going on? Git branch, there it is. I'm going to make the change. Convert Celsius to Kelvin. I believe it's just simply adding a constant to the Celsius value. I'm going to save that. Git status tells me it's changed. Well, what that change was, git diff, there it is. Let me add the file. Now I'm ready to commit it. But I'm going to just say git commit. Remember before I was saying git commit -m, then the message, I'm going to do git commit. This goes in and opens up a text editor. Then I can go write the commit message. This is great if I want to write a longer commit message. So I'm going to say add conversion from Celsius to Kelvin. And let's say I want more information to this commit, right? This is sort of the header, right? You think of this as composing an email that describes a change. This is the header, right? The subject line of the email, the subject line of the commit message. And then I can have a longer paragraph or longer discussion about the why or some things to be aware of. And I'm going to say here is our clients need an easy way to convert to Kelvin as it's the basis. I'm going to truncate this to 72 lines and 2 characters per line is a strong convention in Git. Our clients need an easy way to convert to Kelvin as it's the basis, the basis, right? Let me fix that right there. Basis for a lot of their simulation workflow or something like that. Save the file. And now if I do git log, then I see that longer message there. Cool. Now you're working on this branch and you realize, well, let me go ahead and create this. What I've added is I added another commit. But this here moves. It moves. So this is my feature, and this is my head. My head points to feature. I called it Kelvin, so let me call it K. Rename this and call it K. We go back to the command line, and I'm ready to merge it into my master branch, but then I realized, wait a minute, there's a bug, right? When I worked on this branch on this feature here, I realized, hey, there's a bug in the Celsius conversion. I could have that change be part of my branch, that Kelvin branch, but maybe it makes more sense that I have it as a separate branch. Separation of concerns, right? Compartmentalization. Git helps me do this compartmentalization. So let me go ahead and create a new branch. Let me first, you check out back to master. I'm back to master. In fact, if I do git log, it doesn't show the recent commit because it's only showing me the commits that are on master on that branch right there. Head points to master, as we see there. Well, now I want to create a new. Remember, it was kind of annoying how we had to do git branch and the git checkout. Well, checkout has a option called -b, which allows me to create a branch and then automatically check to it. I'm going to call this fix bug. Let me go and fix the bug, right? I'll put up temperature py. Notice, hey, wait a minute. The file doesn't have the Kelvin, the added Kelvin function. Well, this makes sense because recall that what I've done now is I've created a reference called fix that points to this snapshot. It doesn't point to this other snapshot. It points to this state. Let me go ahead and create the change. And I believe I want to convert Celsius to Fahrenheit. I got to multiply first, right? I got to multiply first and then add 32. I always have to tell myself, okay, 0 Celsius is 100 Fahrenheit. Wait, messed that up. Right, 100 Celsius is 212 Fahrenheit. So I got to multiply and then add the 32. All right. Let me do git diff. Oh, there's a change. Let me git add temperature py. Let me commit the change with a commit message already there saying fix bug in Celsius conversion. And now what I'm going to do here is I'm going to do git log. But I'm going to do something else besides git log. I want to see this entire data structure right now, right? I want to see this data structure. And in order to modify what I've done is I've added a new commit. And since this feature is going to move, sorry, this bug fix, that's what I really call B maybe, move here and I'm going to change that. It should move there. Oh, now I moved head as well. Sorry about that. I'm gonna call this B for bug fix. Sorry, this is points to head. Right, this is how my project looks like. My master main branch points to this commit. My Kelvin branch points to this commit, this stage or this snapshot, and this bug fix points to this commit, and head points to that branch. I'm going to do git log, but I want to show more of this data structure in this log here. Now, this is kind of a long command. I have a little device, a little way to remember it. I saw this on the internet. Every time I do git log, I think of a dog. All decorate. Let's have a one-liner. Let's have it all in one line. One line. And let's have the graph. And notice it shows me this little sketch of the data structure we're composing. Right? These two commits, then we branched off, and then we have this other branch. And it tells us these references, those sticky notes, where they point to. Master points to this snapshot. Kelvin points here. Head points to fix bug, which then points to this commit right there. Cool. Right, there it is. Now I'm ready to do the merging. I'm going to git checkout to master. I want to get back to the master branch. Now let's sketch what we have here. I'm back onto master. So let me move head to point to master. So now what I want to do is I want to bring this commit into the master branch. Now, if you were to think about it, is how do I move this reference? This branch is really a reference. It basically points to a commit. How do I move it so it now points to this state? Well, in some ways, all I need to do is kind of fast forward into history, right? Fast forward its way through. Once again, you can think of this as representing a cassette head and fast forwarding. I grew up with cassettes and VHS and so forth, though. One of the things I want to clarify is the terminology that get used is, right? We're going to fast forward this reference to point to this other state. So we can do that through a merge command. When we do merge it, it's going to fast forward to this state here. It's going to move master to point to this state here. And head will automatically travel to where master is pointing to. Because recall that head is directing itself to master. So let me go back to the command line. Git merge Kelvin. Let me go ahead and invoke that command. Notice how head points to master, and master and Kelvin both reference this commit. Now let me merge in the other change. Let me get back to master. And now I want to have this snapshot. I want my master branch to then point to this snapshot here. Well, can we do a fast forward? Well, no, we can't just fast forward this commit. I mean, this reference here to point to this commit, right? There's sort of no way it can travel to. It has to kind of go back in some way and then connect to it. So we cannot fast forward when we do a merge. What Git is going to do is it's going to create what's called a merge commit that has two parents. And that's how it's going to reconcile the fact that I cannot fast forward. There you go. Let's see this in the command line. Git merge fix bug. The text editor opens up saying, hey, what do you want the commit message to be to the merge commit? I'll just keep the default. Now, if I do git log, well, there it is. But let me go back to that longer git log, right? When I git log, I think of a dog, all, decorate, one line, and graph. That's how I have to remember it. And there it is, right? There is our data structure right there that we've built. Think of git commands as manipulating, creating this data structure. We're adding commits, and we're changing the references, the branches to those, to what those references point to. We're updating this data structure there. All right, I'm sort of short on time here. The one thing I want to bring up is that you want to make sure that there's actually a convention of what should be like a good Git history, right? Things like here have code and all this gibberish here. That's not useful. If I'm a developer, I don't want to see these Git messages because they're not useful to me, right? This will convey the who, what, when, where, why. This doesn't do a good job of the why and the what, right? That's one thing I want to point out here. You want to think of these commits as being atomic and self-contained, right? They're doing one thing. I could have had one commit that represented the bug fix and the added feature, but those are really two different things, right? If I find myself in the Git commits saying fix bug and add new feature, they should be different commits. Should be different states in history that I'm keeping track of. The last thing I want to do here, the last thing I wanted to demystify to students is that Git is different from GitHub, right? GitHub is owned by Microsoft, I believe, these days. Git was developed by the person who developed the Linux kernel. And the Linux kernel, not a good history between Linux and Microsoft, right? Git and GitHub are different. Git is a version control software. GitHub is simply a service that lets people host remotely Git repositories. It's not the only player in town. Yes, it is the major player in town, but there are other services out there like GitLab, Bitbucket, and so forth. Right? GitHub is a service that lets one host their Git repository on a remote server. So you can then have a copy on a remote server that other people can then pull from, clone from, and propose changes to. That's the service that GitHub provides. Don't conflate the two. I'll be honest, when I hear people conflate the two between Git and GitHub, that tells me, yeah, maybe they really don't understand Git, right? Git is the software. GitHub is a service that lets people easily host Git repos. Just like a photo I have on my computer is different from some social media service I'm using to host that photo, host that file for others to see and comment on. All right. That concludes our introduction to Git. There are more things to Git, but hopefully you're left with better understanding how Git works underneath the hood and more confidence as you invoke those commands in the command line for Git. All right, pass it over to Sierra.
Thanks, Don. If you have questions for Don, please drop those in the Q&A box. We will open it up to questions in a couple of minutes. We just have a little bit more information about our programs, and then we will open up to the Q&A. So make sure you drop your questions in there. We get asked quite often about our programs if we offer scholarships, and the answer is yes, we do. We admit 2 types of students into our programs. We have our fellow spots that are offered tuition-free scholarships for our full-time program, and then we also have our scholar acceptances as well. Scholars will pay tuition to participate in our program. They're not required to interview solely with our hiring partner network, and they maintain their current employment. And you'll still have the same access to curriculum, resources, and tools as our fellow students. And then full tuition scholarships are not offered for the part-time program. We also are going to continue to offer our Women of Excellence in STEM scholarship, as well as our Equity and Diversity in Data scholarship for our 2023 cohorts. These scholarships aim to help remove barriers and provide opportunities for women, veterans, LGBTQIA+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. Those applications are open now. They are due before the application closes for spring. So if you haven't applied yet and you're interested, please visit our website, dateincubator.com/programs and scholarships to review the qualifications and to apply today. Another big component of our program that we really pride ourselves on is helping our students not only grasp these data science and data engineering concepts, but also getting placed in that field. We see about 97% of our students that go through our program are currently employed outside of academia, and 88% are employed within 6 months of completing the program. That's really part of the challenge, not only learning the content, but being able to transition into a data role that you're happy with. And that's where our program stands out, because we help you to do both. So where are our graduates now? Where are they working? What are they doing? Our graduates are working in over 55 different industries. And some of the most common industries we see are computer software, IT, financial services, and biotech. And some of the typical roles we see are data scientist, data analyst, data engineer, research scientist, and many more. The titles and roles vary depending on the company and industry, but these are just some of the roles that we've seen in the past. We've also seen that the interest for data engineer role are increasing. We've seen about 40% growth year over year. And we also see that our graduates are typically earning 16% more than industry standard, which is very exciting to see. Here's a short list of some of our hiring partners. If you would like a more detailed list, please email us admissions@the-data incubator. We'll be happy to share that with you. In addition to our scholarships options, we do also offer financial aid. So we've partnered with LEAP to provide an income sharing agreement. It's a great option for a lot of our students. You can participate in the program with just a deposit down, and you won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also offer 2 additional finance options through LEAP, a tuition installment plan and a contingent payment plan. So the tuition installment plan allows you to make fixed monthly payments over 12 months. And then the contingent payment plan, you're able to participate in the program with just a deposit down, similar to the ISA, and won't be required to make any payments until you graduated and are working and earning more than $50,000 annually. After that, you'll make fixed monthly payments over 24 months. And then we also provide loans through Ascent. Ascent offers 3 options, one being deferred repayment, interest-only repayment, and immediate repayment options. And then lastly, for many of our part-time programs, companies are willing to sponsor or pay for their employees to go through our program. It's a great opportunity for a lot of our students. You're able to learn great things in the evening that you're able to apply to your job during the day. So if this is something that you think your company would be interested in or you'd like to present to them, we do have a letter that we can provide you that will help lay out the program and all of the benefits of attending. So let me see the next slide. Where are we right now in our application cycle? Well, our spring application actually closes on Friday, and our winter cohort is about 2 weeks into the program, but there's still time to apply. If you're interested in spring, again, that application will close on Friday, January 27th, and then you'll have 72 hours to complete the coding challenge from the time that you open it, and the challenge deadline is Monday, January 30th. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We're not able to reopen the spring application after that deadline. So if you're interested in applying to our program, which I hope you are, you can go to thedateincubator.com/apply to submit your application. And if you have questions about your specific situation, this presentation, or going through our application process, please reach out to us at our email. We'll be happy to answer your questions there. And if you're here and you're interested in our summer application, maybe that timing doesn't work for you, we do have that summer application opening very soon as well. So at this point, I will open up the Q&A. If you have questions in the chat box, please move them over if you haven't already, and we will answer some of those today. So first question, so any credit prerequisites for the program? Not sure if that's, Dawn, would you have an answer for that one?
I'm not sure what they're asking behind that. What credits? Are you assuming maybe what
like
what prerequisites, or maybe so like what what prereqs are required? So we make everyone do go through the challenge, right? So in some sense, we are vetting you. Before you enter the program, we do send you a link to what's called our 12-day program. We want to make sure that all the people going to the program have the same foundation coming in. Right, there are some things you're more comfortable with and others that you're not. So the 12-day program is really going to make sure you're up to speed with the skills you need to really get the ground running on day one.
And then this next question here is ISA now available for Canadian citizens? So the ISA is available for if you have a U.S. Social Security number. You're not required to be based in the U.S. So if you have some type of visa type that grants a U.S. Social Security number and maybe you're based abroad, then you're eligible to apply for the ISA. Any other questions? We might have time for maybe one more. If not, if you also have a question, again, please email us. We're more than happy to schedule a call with one of our enrollment counselors.
There is one in the chat that I'm not sure made to the Q&A. It says, can we create a pull request to the master for the bug fix branch on the terminal?
Okay, I think that was also, they also posted it in the Q&A. So point to that answer there. The answer is it depends on how this remote, where this remote server is being hosted. GitHub does have a command line interface, so presumably you can do that through their command line interface. GitLab probably has something as well.
Okay, thank you so much, everyone, for joining us today. Again, this session was recorded. You will receive a recording as a registered attendee. Please email us if you have any questions, and don't forget about our regular admissions application deadline. It is this Friday. If you haven't applied yet, please do so. And then our summer application will be opening next week. Thanks, everyone. Have a great day.
Bye.